Alright, this is a little bonus review, not on your study guide. So, we're going to do direct variation and inverse variation, and just remind you of what that is. So if you're seeing a picture of it, it's easy to tell them apart, because your direct variation is a straight line, but it's diagonal and it always goes through the origin. I missed it right there. Try to get that right through the origin. There you go. Our inverse variation is a curve, and it curves up around like that. Okay? So when you are doing direct variation and inverse variation, the rules sound similar. So let me give you a table that helps you out. So if I had 1, 2, and 3, and I was having direct variation, then you would multiply by the same thing to get your second thing every time. So it looks like this: y equals ax or kx. So in this time I'm going to do y equals 4x, and if I do that, that means I need to multiply by 4 from every x to every y. So 1 times 4 is 4, 2 times 4 is 8, and 3 times 4 is 12. Now let's switch over to inverse variation, and this time these two multiply to the same number. So if I have like 3 and 8, 6 and 4, and 2 and 12, then that same number is 24 that they're multiplying to. We call that our constant, just like over here our constant was times 4. And what we say for this equation is y equals k divided by x. So this one specifically would be 24 divided by x. So if you're having trouble understanding that equation, like this one makes sense a lot, but the inverse variation one, what they're doing is saying, well, if you already have your x value, all you have to do is divide by it to figure out what your y value should be. So if you know it's supposed to go to 24, divide 24 by 3 and you know it has to be 8. Divide 24 by 6, you know it has to be 4. Divide 24 by 2, you know it has to be 12. So it's just a fancy way of doing all that.